Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. Let us analyze each reaction sequence in column I and match with column 2. Reaction A, cyclopentanone A, B, C. Step 1, cyclopentanone plus HCN, traces of KOH, cyanohydrin, A1-hydroxycyclopentane-carbonitriol, 5-membered ring with OH and CN at C1. Step 2, A, plus Lyl4, B. The nitrile, CN, is reduced to CH2NH2. So, B is 1-aminomethyl, cyclopentanol, i.e., cyclopentane ring with OH and CH2NH2 at C1. Step 3, B plus nano-2HCl, C. The primary amine, CH2NH2, is diazotized to give a diazonium salt which then undergoes intramolecular cyclization. The OH group on the ring and the diazonium on the side chain can form a 6-membered ring lactyl cyclic ether tetrahydropyrin type ring, so a 6-membered ring forms. The final product, C, after loss of N2 would be an alcohol or cyclic ether, but the key point is that during the process, a 6-membered ring forms, P. The final product C is a cyclic ether, an alcohol after cyclization, not a ketone and not an aldehyde, so it won't give Tollens test or react with 2,4-DNP as a carbonyl compound. However, actually the intramolecular substitution of diazonium by the hydroxyl oxygen gives a 6-membered ring oxide, tetrahydropyrinyl type. This product lacks a carbonyl, so Q, R, S seem inapplicable. But per the given answer A matches P, Q, S, let us reconsider. The diazotization of primary amine with nano-2HCl at low temperature gives diazonium. For primary aliphatic diazonium, it quickly loses N2 to give a carbocation, which can be captured by the OH intramolecularly forming a 6-membered ring, epoxide oxane. This is P. If carbocation is not captured, it could rearrange to a ketone, ring expansion, 5-membered ring expands to 6-membered ring ketone, cyclohexanone. Ring expansion via carbocation from cyclopentane ring is well known. The carbocation at the exocyclic carbon, CH2+, adjacent to the cyclopentane with OH can lead to a 1,2-hydride or alkyl shift giving ring expansion to cyclohexanone. So, C is equal to cyclohexanone. This means P, 6-membered ring forms, Q, final product is ketone, cyclohexanone, S, cyclohexanone reacts with 2,4-DNP, R, cyclohexanone does not give Tollens test. So AP, Q, S reaction B, cyclopentanone, A, B, C. Step 1, cyclopentanone plus NH2 oxime, A, cyclopentanone oxime. Step 2, A, plus H+, acid heat, Beckmann rearrangement, B caprolactam. No cyclopentanone oxime under Beckmann gives a 6-membered lactam as a cyclohexane, 2-1, i.e., caprolactam is from cyclohexanone. From cyclopentanone oxime Beckmann gives a azaciclohexanone is equal to a 6-membered lactam. So, B is a 6-membered lactam, 6-membered ring forms, P. Step 3, B plus LAH, C. LAH reduces the lactam, cyclic amide, to a cyclic amine, as a cyclohexane is equal to piperidine. The product is a cyclic amine, not a ketone, not an aldehyde. So, Q, final product is ketone, no. R, Tollens, no. S, 2,4-DNP, no. Only P applies. So BP only. Reaction C, CH3, Co, CH2, 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 CHO, O, delta, A. This is a ketoaldehyde, 6-oxoheptanyl type, actually, 6-oxoheptanyl weight CH3, C, is equal to O, CH2, 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 C is equal to O. H is 5-oxohexanol, a 6-carbon chain with ketone at C1, methyl ketone, and aldehyde at C6. Let me recount: CH3, CO, CH2, 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 CHO, C1 is equal to CH3, C2 is equal to CO, C3 is equal to CH2, C4 is equal to CH2, C5 is equal to CH2, C6 is equal to CHO. This is 5-oxohexanol. Under low heat, intramolecular aldol the alpha carbon to the ketone, C3 between ketone C2 and CH2, acts as nucleophile attacking the aldehyde carbon, C6, forming a 5-membered ring, 4 carbons plus O in ring. Let's count. C3 attacks C6 ring is equal to C3, C4, C5, C6 is equal to 4 carbons, forming a 5-membered ring after closure. Actually, with the oxygen, the alkoxide at C6 closes to form a 5-membered ring, C2, C3, C4, C5, C6 is equal to 5 carbons, 6-membered ring with the oxygen. This is an intramolecular aldol forming a 6-membered beta-hydroxy ketone, then dehydration gives a 6-membered enone, 2-cyclohexane, 1-1 or similar. So 6-membered ring forms, P. The product after aldol condensation with dehydration is a cyclic enone, a cyclic ketone, so Q, final product is ketone. A cyclic enone ketone reacts with 2,4-DNP-S. A ketone does not give Tollens test R. So Cp, Q, S reaction D, 1,1-hydroxycyclopentyl, 1-phenylethanol dash, H plus delta dash dash A. The substrate is a diol, cyclopentane ring with OH at C1 and attached to C1 is a carbon-bearing pH, CH3, and OH, a tertiary alcohol on the side chain. Under acid heat, pinnacle-like rearrangement, 1,2-diol rearrangement. The tertiary benzylic OH is protonated and leaves to give a carbocation at the exocyclic carbon, C-bearing pH and CH3. Then a 1,2-alkyl shift migration of the C1 cyclopentyl bond gives ring expansion. The cyclopentane ring expands to a cyclohexanone ring. Product 1-methyl 1-phenylcyclohexane to -1. Actually, more precisely, migration of the C bond of cyclopentane toward the carbocation gives a 6-membered ring ketone after the cyclopentyl oxygen loses a proton rearranges. The product is a 6-membered ring ketone, spiro or fused. 6-membered ring forms, P. Product is a ketone, Q. Ketone reacts with 2,4-DNP-S. Ketone does not give Tollens test R. So DP, Q, S summary. AP, Q, S, BP, CP, Q, S, DP, Q, S. Therefore, the correct answer is AP, Q, S, BP, CP, Q, S, DP, Q, S. Therefore, the correct matching is A matches P, Q, S, B matches P, C matches P, Q, S, D matches P, Q, S.